Hello wonderful person, this is Anton, and let's start this video with the first ever image of something we've never seen before, a quasi-moon of planet Earth. And so what you're seeing here, this rugged gray mass against the black void of space, this is an object referred to as 469219 Kamo'oalewa. The object you can learn more about in some of the videos in the description, because for several years, researchers have been trying to figure out one thing. Is this actually an ancient piece of the moon? In other words, this object, that's technically considered to be a quasi-moon of planet Earth, with the orbit you see right here, for several years now have been suggested to be a chunk of the moon that was possibly ejected by some kind of an ancient collision, and is now basically orbiting around the solar system. But in July of 2026, Tianwen-2, a Chinese spacecraft, was able to capture this beautiful shot from just 20 kilometers away, and is now essentially going to finally answer this very important question. Where did this come from, and what exactly is it? And so after a journey of more than a year, and traveling for approximately 1 billion kilometers, China's first asteroid sample return mission has finally arrived at its final destination. And so for China, and obviously for humanity as a whole, this is going to be a very interesting mission. And not just because we reached another rock where we're going to be collecting samples, but once again because this object is the official quasi-moon of Earth, a mini-moon that's been dancing around the planet for at least a century. And so let's discuss some of the recent discoveries from this mission, talk about the strange nature of this object, and why the samples collected by Tianwen-2 could completely change our understanding of the Earth-Moon system. And first, let's start with the target itself, the object that was accidentally discovered back in 2016. And its name, Kamo'oalewa, comes from the Hawaiian chant that refers to some kind of an oscillating celestial object. But in the last few years, quite a few of these objects have been officially confirmed, with the planet Earth now officially containing 8 quasi-moons, or 8 quasi-satellites that appear to orbit around the planet, but in reality orbit around the Sun. And so technically this is not a true moon because it's not gravitationally attached to our planet, and it's called a quasi-satellite or a mini-moon because it's gravitationally bound to the Sun. And you can kind of see the orbit of this object from the perspective of planet Earth right here, although in reality it's just orbiting the Sun. And so because it shares an orbit that's almost identical to Earth's orbit, from our perspective it appears to loop around the planet, even though it's technically doing its own thing. And based on some of the initial discoveries and based on the initial analysis, we knew that this is a relatively small object, anywhere from 15 to 100 meters across. So basically the size of a small building. But it's also a very fast rotator, spinning on its axis every 28 minutes. And it's this rapid spin that's going to make it extremely difficult for the spacecraft to land or to even approach this. Despite of this, China is going to try this very soon. But this is also one of the most exciting such objects because it seems to be the most stable quasi-moon we've discovered so far. It's been in orbit around Earth for at least 100 years and will most likely stay here for at least a few more centuries. But what exactly is China doing here, and what's their eventual plan? Well, the Tianwen-2 mission launched on May of 28, 2025. And this is technically a dual-target mission. And the primary goal here is to spend at least 9 months orbiting this object in order to study it, and in order to understand its shape, composition, and overall properties. But once the mapping part is finished, the most exciting part is going to be the sampling. And so unlike previous missions such as the OSIRIS-REx that collected samples from the asteroid Bennu, or the Japanese Hayabusa 2 mission which collected samples from Ryugu, Tianwen-2 is prepared to use 3 different methods in order to collect a piece of this rock. The first method is going to be touch and go, briefly touching the surface in order to collect dust. Then it's going to try hovering, using a robotic arm. It's going to scoop up material while hovering just above the surface. And lastly, it's going to attempt an anchoring and attachment approach. This is actually the most complex approach, and here the spacecraft is going to physically attempt to attach itself to the asteroid using a claw and spike mechanism to collect both the surface and subsurface samples. And if successful, the probe is going to depart in April of 2027 and head back to Earth. And as it flies by our planet in late 2027, it's going to release a capsule containing at least 100 grams of the asteroid material, with the capsule eventually re-entering the atmosphere and retrieved by Chinese scientists on Earth. And it's actually these samples that are going to be super exciting, and for the reasons I mentioned previously. Because here these samples are going to try to answer that extremely intriguing question. Is this an actual asteroid? Or is this an ancient piece coming from the moon? And that's because based on the spectrum analysis, or basically the way it reflects light, a few years back initial studies suggested that it seems to actually resemble lunar material. And specifically, it seems to resemble soil that's usually located on the surface of the moon that has now been dramatically weathered by space radiation. And so one of the biggest unproven ideas about this particular rock was that sometimes in the past, a fragment of the moon was basically released into outer space, very likely blasted by some kind of a massive meteor impact, and for the past few millions of years has been flying around the planet, eventually becoming this. And most likely coming from this crater, referred to as Giordano Bruno crater, that was indeed created a few million years ago. And so because the regolith in this location seems to reflect the light in a very similar way to this particular asteroid, it eventually led to this intriguing hypothesis. And since its orbit is also so extremely close to planet Earth, it of course made at least some sense. But despite of this, a lot of more recent data, especially data from the James Webb Space Telescope, revealed that the spectrum might not actually match as well as we hoped. As a matter of fact, it seems to be less red and more neutral than previously believed, with the new data suggesting that this might actually be just a typical LL chondrite asteroid, or a typical stony asteroid, or something else very similar such as an S-type or E-type asteroid that we often find in the same location in space. And so for the past few years, scientists have been trying to figure out which hypothesis makes more sense. Is this a lost piece of our own moon? Or is this just a common asteroid that just happens to have an Earth-like orbit and a surface that kind of resembles lunar soil because of extreme space weathering? Which is why this particular sample is going to be so important for scientists in these fields. And so here, by analyzing isotopes and conducting mineralogical studies, we're going to know for sure. But apart from this, there are some other implications coming out of this mission, and some other questions it might answer. And that's because after Tianwen-2 drops off all of its samples on the planet, its mission is not going to be over. In fact, it's going to use Earth's gravity as a slingshot to propel itself toward its second mission, the comet referred to as 311P. The comet that you see right here. And this particular object gained a lot of scientific attention because of its unusual appearance. It was actually observed by the Hubble Space Telescope and was really strange because it contained 6 comet-like tails. And so unlike normal comets, which normally develop tails because of sublimation of ice as they approach the sun, here these tails seem to be the result of some kind of a mass loss because of the rapid spin of this object and because it's essentially falling apart. And so because of this rapid spin, it seems to shed a lot of material from the surface, stretching it into these very long streams with the help from solar radiation. And while this is technically an asteroid, it's actually its comet-like behavior that made this object so interesting and so unusual. With additional observations from 2018 even potentially revealing some kind of a moon that seems to orbit around it. In other words, this could be a binary object, making this visit even more exciting. But it's not going to visit this object before mid-2030s. As a matter of fact, it's going to arrive here sometimes around January 2035. And upon its arrival, it's going to once again enter the orbit and attempt to conduct an extremely detailed remote sensing study by basically scanning the surface and figuring out what's going on here. And the implications in this case are going to be quite significant. By studying both the quasi-satellite of Earth and this bizarre cometary asteroid, it will help scientists find the line between these two types of objects and essentially find some kind of a continuum, helping us define them a little bit better. But more importantly, if the Quasi-Moon of Earth turns out to be an ancient piece of the moon, it will also tell us a little bit more about the violent history of the Earth-Moon system, and tell us a little bit more about how material is exchanged in the local neighborhood and how some of these objects potentially end up on other moons and other planets. But as of right now, as of the making of this video, in mid-July of 2026, Tianwen-2 is still in a safe orbit approximately 20 kilometers away from this object, and it will actually take at least a few months to finally come close enough to start mapping the surface. And so it will take a few months before we get better pictures. But for China, this is a really important mission because for them there's a lot of firsts. First asteroid sample return, first attempt to anchor to a small body, and first long-term exploration of a deep solar system beyond the moon. Something that has only been achieved by a handful of space agencies in the past. And so I'm definitely going to be following the results from this sample study quite closely, and we'll come back and discuss more of this once there are some additional results. But in the meantime, you can check out some of the previous videos about this object in the description below. On that note, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.